Okay, so to start with, I've got some vocabulary words here, 5 of them to be exact. What I would like students to do at this point is go ahead and copy these notes, both the vocabulary word and the definition that follows them. So go ahead and pause here. We're going to be making some examples of these vocabulary words in just a moment. So I have gone ahead and created a set of parallel lines. I'm not going to name the lines because I'm just going to refer to the angles as angle 1, angle 2, angle 3, angle 4, 5, 6, 7, and 8. So we have 2 parallel lines, the ones that are on top and bottom. This line that intersects them is our transversal. That's pretty simple. If we go back to the definition, a transversal is a line that intersects 2 parallel lines. And we can say that that line that's kind of going up and to the right intersects both the top line and the bottom line. I'm going to continue with the notes on this page because transversal is pretty basic. I'm going to now talk about corresponding angles. So corresponding angles are the same angle in a different spot. And so the way that we can see that is that if we look at these 4 angles, they all match these 4 angles down here. Like I could literally pick up the angles from the bottom and lay them on the angles on the top, and they would be exact copies of each other. So if we look for angles that share the same spot in a different place, so the upper left part of the transversal, we can say that our corresponding angles are angle 1 and angle 5. We can also say that angle 2 is corresponding to angle 6. We can say that angle 4, you can see I'm kind of boxing these figures in with different shapes to match them up. So 1 and 5 are circled, 2 and 6 are in a square, 4 and 8 are in a triangle. I'm just showing that they match each other. So angle 4 and angle 8 are corresponding. And lastly, angle 3 and angle 7 are corresponding. If they are corresponding, if we go back to the definition for a moment, there are 2 angles in a different spot. I left the part out of the definition that corresponding angles are congruent. So we could also make congruence statements about these angles. So if you remember, we always go from a statement of congruence to a statement of measure. So we could make statements like angle 1 is congruent to angle 5. I'm just copying that from my list on the right. That means the measure of angle 1 is equal to the measure of angle 5. I'm going to do one more of those and then move on. Let's do 4 and 8. We know that 4 and 8 are corresponding. We know that corresponding angles are congruent. So angle 4 is congruent to angle 8, which means that the measure of angle 4 is equal to the measure of angle 8. I'm going to pause here so you can take notes on transversal and corresponding angles. Again, corresponding angles are angles that are the same angle in a different location. And with parallel lines, they are always congruent. Okay, and so this time we have alternate interior angles. Now, if we look at the definition of alternate interior angles are angles that are on the opposite side of parallel lines. Sorry, that should say transversal, actually. opposite sides, same side. We can change this right now. Angles that are inside of parallel lines and opposite sides of the transversal. No, that's correct. Wording is kind of tricky. So we're looking for angles that are inside parallel lines, that's interior, and opposite sides of the transversal, that is alternate. So we can think about alternate interior angles as opposite angles on the inside. This time there are only going to be 4 alternate interior angles because there are only 4 angles on the inside of this figure. Angle 3 is on the inside of the figure, and so is angle 4, but it is not on the opposite side of the transversal and touching the other parallel line. So 3 and 5 are alternate interior angles. They're on opposite sides of the transversal and opposite sides of the parallel lines. Now, angle 6 and angle 4 are alternate interior angles also, because they are on opposite sides of the transversal, but inside the parallel lines. So alternate interior angles are congruent. So that means that angle 3 is congruent to angle 5. If angle 3 is congruent to angle 5, we can also make the statement that the measure of angle 3 is equal to the measure of angle 5. Moving on to the other pair, angle 4 is congruent to angle 6 because of alternate interior angles. If they are congruent, their measures are equal, so the measure of angle 4 is equal to the measure of angle 6. Now those are the only alternate interior angles because they are the only angles that are on opposite sides of the transversal and opposite sides of the parallel lines and inside the parallel lines. Go ahead and pause here. Okay, alternate exterior angles. What we have in the case of alternate exterior angles, alternate means the opposite side. So the opposite side of the figure or parallel lines and the opposite side of the transversal. Pardon me, I'm having trouble with this cough. It's been horrible. So I could say that angle 2, I find the angle that is outside and opposite on the bottom of the figure. That is alternate exterior. So alternate is the opposite or the other side, and exterior is outside. So I could make the statement that angle 2 is congruent to angle 8. Because they are congruent, we can say that their measures are equal, so the measure of angle 2 is equal to the measure of angle 8. There's only one more pair of alternate exterior angles. That's going to be angle 1. I almost said angle 6, but that is on the inside of the parallel lines, not the outside. So I'm going to go to the outside, which puts me at 7. So angle 1 is congruent to angle 7 because of alternate exterior angles. So the measure of angle 1 is equal to the measure of angle 7. Okay, go ahead and pause here and take those notes. And our last one for today is going to be vertical angles. Now we have talked about vertical angles in class before, but it was only with figures that look like this. And you would have said right away, oh look, that angle and that angle are congruent, and that angle and that angle are congruent because of vertical angles. It's pretty quick to see in a figure like that. What we need to do in a figure like the one above is apply the same concept, but recognize we're only looking at part of the figure at a time. So for vertical angles, we can only look for angles that share a vertex. And so these 4 angles share a vertex, so there must be some vertical angles there. And these four angles share a vertex, so there must be some vertical angles there. We are going to treat the top part and the bottom part separate of each other for the purpose of vertical angles. So for instance, if I look at angle 1, I'm looking for the angle that is opposite of angle 1 that shares a vertex. That would be angle 3. Vertical angles, angle 1 and angle 3 are vertical. I can make the statement that angle 1 is congruent to angle 3. So the measure of angle 1 is equal to the measure of angle 3. Continuing, angle 2 shares a vertex and is opposite with angle 4. So we can say that angle 2 is congruent to angle 4, which means the measure of angle 2 is equal to the measure of angle 4. Now looking at the four angles in the bottom, I can see that angle 5 shares a vertex and is opposite of angle 7. So we can say that angle 5 is congruent to angle 7, which means that the measure of angle 5 is equal to the measure of angle 7. And then lastly, we can see that angle 6 and angle 8 share a vertex and are opposite of each other. So we can say that angle 6 is congruent to angle 8, which means that the measure of angle 6 is equal to the measure of angle 8. So, with that, those are examples of vertical angles. Let's go up our list. Vertical angles, alternate exterior angles, alternate interior angles, corresponding angles, and a transversal. I'm going to go ahead and pause here so you can take notes on vertical angles. And I'm going to make a comprehensive list of all the relationships that we could see on a set of parallel lines like this. So we need to get good at recognizing these very quickly because we are going to use them a ton. So corresponding angles, I'll start with angle 1 and work my way around. Angle 1 and angle 5. And I will say that angle 1 is congruent to angle 5. I'm not going to worry about making a measure statement right now, just a congruent statement. I see angle 2 and angle 6 are corresponding. So angle 2 is congruent to angle 6. I see that angle 3 and angle 7 are corresponding, so angle 3 is congruent. Just did that twice. To angle 7. And I see that angle 4 is congruent to angle 8. Alternate interior angles. This one's a tiny bit more difficult to see, so I will circle them and then delete my marks. So I'm going to start with angle 3. That is on the opposite side of the transversal and across the figure. Inside the parallel lines is angle 5. So angle 3 is congruent to angle 5. Because of alternate interior angles. Angle 4, again I go to the opposite side of the transversal and the opposite side of the figure. Angle 4 is congruent to angle 6 because of alternate interior angles. And there's only two pairs there because there are only two pairs or four angles that are inside the parallel lines. And I should have put parallel marks on my lines. I probably need to go back and do that for all of them actually. Alternate exterior angles. We're going to start with the exterior, which is going to be angle 1. Opposite side of the transversal and outside the figure is angle 7. So because of alternate exterior angles, angle 1 is congruent to angle 7. And then the other angle that is outside the parallel lines on top is the 2. The opposite side of the parallel line and of the transversal and outside is angle 8. So angle 2 is congruent to angle 8. And last, these are pretty easy. We have vertical angles, angle 1 and angle 3, angle 2 and angle 4. Share a vertex and are opposite of each other. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. In the bottom piece there, angle 5 shares a vertex with 7 and is opposite of it. So angle 5 is congruent to angle 7. And then lastly, we have angle 6 shares a vertex with angle 8, and they are opposite of each other. So angle 6 is congruent to angle 8. That's going to be it for this video. I hope this is helpful. There is an assignment in ALEKS for you today that I would like you to work on after you finish this. If you do not have a Chromebook, you can borrow one from the back cart, but you are not allowed to go to your locker. If you need a Chromebook, you can share with a person that is near you. There will be no leaving the classroom today.